2021 projectiles, question 3b. A plane inclined at an angle 30 degrees to the horizontal. A particle projected from a point G up the plane with initial speed u at an angle of 30 to the inclined plane. So with the inclined plane, we need to work out our accelerations and taking the inclined plane as the I direction. We'll draw a little diagram here. Here's my inclined plane. If we imagine the projectile is at this point, the particle, gravity is coming down in this direction. So this is G. The plane continues up in this direction. We have our angle here of 30. So corresponding angle in here will be 30, meaning this one would be 60. And we create our right angle triangle going up in this direction to meet gravity. Here we're going to have a 30 degree in here. So just taking this right angle triangle outside, my right angle, and this is my I, and this is my J, and my 30 up the top. We'll use the angle that's in the question. The I direction, with gravity being the diagonal here, the hypotenuse, is going to be G sine 30 in the I direction. This is my acceleration. We're talking about minus G in this case, it's bringing it down, so minus G sine 30, and the acceleration in the J direction is going to be minus G cos 30. And the sine of 30 is a half, so minus G over 2. Cos of 30 is root 3 over 2, so minus root 3 G over 2 for my two accelerations. Now my initial vector. Up here we've got our U and we have our 30. So it's going to be U cos 30 in the I direction plus U sine 30 in the J direction. So cos of 30 is root 3 over 2. So root 3u over 2 in the I direction plus sine of 30 is a half, so just u over 2 in the J direction. So if we set up our equations now, we can say that d, or the displacement here at this point, s of y is equal to 0. So the displacement in the y or J direction is ut plus a half at squared. This is where we need our accelerations. So u in the J direction is u over 2. So we have u over 2 times t, or ut over 2. The acceleration in the J direction we have here minus root 3g over 2. So we put the minus first, it's a half, and then the acceleration. So you're going to have two 2's on the bottom, root 3g over 2. And that's times t squared. So the time taken to get to the landing point, we'll be able to figure out here, is going to be, if we factor out the t, we're going to get t times u over 2 minus root 3g over 4 times t. And letting this equal 0, we get our initial time, where it hasn't started yet. Time is equal to 0, or u over 2 will be equal to root 3 gt over 4. Multiplying by 4, we're going to get 2u is equal to root 3 gt. You can obviously simplify this quicker if you want. The time taken is 2u over root 3g. So now we need to look at the displacement in the x direction or the I direction. So that would normally be ut with the the horizontal plane, but here we have the acceleration for s of I or s of x. So the initial is this root 3u over 2 times the time, which we've just gotten to be 2u over root 3g. Sorry, they're the wrong way around. Root 3g, and then the acceleration we said in the I direction was this minus g over 2, so plus a half by minus g over 2, so just put the minus in first, g over 2 by t squared. So t squared down here, if you want to write it out, t squared is going to be 4u squared, squaring top and bottom, over 3g squared times 4u squared over 3g squared. So we need to simplify this, so over this side the 2's will cancel, The root g's will cancel. So it looks like we're left with u squared over g minus, over here the two 2's will cancel with the 4. We have a u squared on top, and that should be root 3, shouldn't it, on the bottom? No, 3. So we're going to have the squared part cancelling with the g, and we're just going to be left with u squared over 3g. So that's like 1 full u squared over g minus a third of u squared over g, so that would be equal to 2/3 of u squared over g. So that's the displacement in what we asked for. Find d in terms of u. Okay, that's d in terms of u. That's s of x. So then when the particle strikes the inclined plane, it bounces vertically upwards. The coefficient between the particle and the inclined plane is e. Find the value of e. Okay, what's the relationship here with the old and the new and e? Let's leave this visible. So when a ball bounces on a smooth plane along the I direction, the velocity in the I remains the same, but the velocity in the j will be multiplied by minus e. So let's apply our velocities before the particle hits and then the velocities afterwards, and we'll see can we get down to a value for e. So we need to look at the new velocities. The velocity in the I direction is going to be u plus at. So what have we got going on for u? We had root 3 u over 2, and the acceleration, what was it? Minus g over 2 in the I direction. So minus g over 2 times the time taken to get to where the ball struck, which was 2u over root 3g. So what's this going to give us? The g's will cancel, the 2's will cancel. So we're going to get root 3u over 2 minus u over root 3. Now we could simplify this. If we cross multiply, we're going to get root 3 by root 3u, which is 3u, then minus 2 by u over the bottom, which is 2 root 3, which is just going to be u over 2 root 3. We could multiply by root 3 over root 3 to get root 3u over 6. Yeah, root 3u over 6, we could write that as either of those, root 3u over 6, whatever takes your fancy. So that's the new velocity in the I direction. The velocity in the j direction, also equal to u plus at. The initial velocity in the j direction was this u over 2, wasn't it? Just double check here. Was this u over 2? So we have u over 2. The acceleration in the j direction was minus, up here, minus root 3 g over 2 minus root 3g over 2 times the time taken to get there, which was 2u over root 3g. So the root 3's and the g's will cancel, as will the 2's. So it just looks like we're going to get u over 2 minus u in this case. So it's a half u minus a full u, which is minus u over 2. So my new vector is going to be root 3u over 6. Keep the thirds on top. In the I direction, minus u over 2. In the j direction, so consider that the old just before it hits, the new is going to be root 3u over 6 in the I direction, minus e times u over 2 in the j direction. So we just need to figure out what angle it hits, and then we can say the j over the I is equal to the tan of the angle. So let's just have a quick look at the diagram again. So it was projected up the inclined plane, and it was at an angle of 30. So it's projected from here, let's say, hits here and bounces straight up. So what can we say? We can say that's a corresponding angle there. That's 30. So therefore this would have to be 60. So the angle is 60 degrees. So we can say the tan of 60 is equal to j. Actually, let me just see here, it's equal to minus e, isn't it? Just say it's equal to e u over 2 j over I over root 3u over 6, which if I just bring it up and multiply times 6 over root 3u, I'm going to get 6e over 2 root 3 equals the tan of 60, which is root 3. So 2 root 3 by root 3 is 6, so 6e equals 6. So e is equal to 1. And what were we asked to show? Find the value of e. Okay, e is equal to 1 for 2021 part 2. Final part of this question.